we will learn about convert a random variable x to a standard variable z. A random variable x having a normal distribution with the mean, mu, and standard deviation sigma can be converted to the standardized variable. You have seen this equation before. Remember, when we use this z-score, we call it as a z-score when we use it to check the outlier for box plot. Remember, what is the cutoff point? If the z value is less than -3, then we know it is an outlier. If you calculate and you get a z value greater than 3, then you know there is also an outlier. So this is exactly the same z-score that you have used earlier to check the outlier. So now what we want to do is we want to convert the normal distribution to become standard normal distribution. So what is the differences here is we try to change it to the standard normal distribution. Why? Because for the normal distribution, we can have any mean value here. So your center line here is the center point where this is your population mean value, and the standard deviation is represented by sigma. When we convert into standard normal distribution, your z value at the center here will be always equals to 0, and the standard deviation for the population is always equals to 1. So when we convert to 0, 1, then is follow a standard normal distribution. Why we need to do this? Because we need to use the standard normal distribution table later to read the values of the probability. This is a standardized normal distribution where the center here will be the mean value equals to 0, and the standard deviation, the spread is the standard deviation equals to 1. As you know, the curve follow a bell-shaped curve which is symmetric. In other words, if you fold them into half, the probability on the left-hand side is equal to the probability on the right-hand side. So this green color region, the probability is 0.5. This yellow color region or the area under the curve is equals to 0.5. Remember, the total probability is equals to 1. So when we divide into half, that means 0.5 on each side. The value above the mean value have a positive value, meaning that if everything above this z mu equals to 0, then you have a positive value. Anything below this mu equals to 0, you will have a negative z value. So this symbol means that the probability from negative infinity to positive infinity will be equals to 1. So let's look at an example. If x is distributed normally with a mean of 100 and standard deviation of 50, the z value for x equals to 200 is, so in other words, you are given the x value 200 and you know the mean is 100 and the standard deviation is 50. So when you read this, I will suggest you to convert them into symbol. So you have your mu equals to 100, sigma equals to 50, and x equals to 200. So how to compute the z-score? Just plug in all the value into the formula, you should get 2.0. So this say that when x equals to 200 is 2 standard deviations or 2 increment of 50 units above the mean of 100. So in other words, when you try to plot this curve for the normal distribution, the x, this is your x-axis, so you have the x value, the unit is dollar, and the center is your mean value 100. Then just now you say 2 standard deviation spread, right? So 2 multiplied with 50, you have 200 here. Okay, so how to convert them into z? 100% when you convert into z, you actually get 0. And this 200, this is what you just computed here. When you plug in the x equals to 200, you actually get your z value equals to 2. So in other words, this question gives you the x value, you need to convert them into z value. So here you will have the mu equals to 0 and sigma equals to 1. So how to check whether you do it correctly or not? You can see that this formula, if I move the sigma to the left hand side, it will become multiplied. So I have sigma z equals to x minus mu. When I move the minus mu to the left hand side, it will become plus mu. So this is how I want to get the x value. If I put it another way, it will become x equals to mu plus z sigma. The second and the third equation, they are the same. I just try to change their position so that you know that x is 200, mu is given 100, sigma is given 50, z is the one that you just calculated, you got 2. So if you put in this value, you calculate on the right side is equivalent to the ones that given in the left side, then that means that your z value is actually correct. Okay, we will stop here for part 1 and we will move to the second part for finding normal probability.